Hey everyone, hope you're doing well. Today, I'm going to cover machine learning fundamentals. So let's get going. So these are the topics that we're going to cover today. What is the intro? What are the different types? What the workflow looks like? How to reprocess the data, and some algorithm followed by how to evaluate the model. So let's start. So what is machine learning? Machine learning is, as you can think about, as a subset of artificial intelligence, like mimicking how human intelligence works. There is a stream of science called artificial intelligence, and machine learning is a part of it. There are more things apart from machine learning as part of artificial intelligence. Hence, machine learning is covering one aspect of it, and that is important aspect where we try to make machine learn the pattern from the data, and of course make some decisions using some, I would say, learning that it has from the past data, and of course with the minimal intervention from human. That's the overall goal of machine learning. So what is the principle of this, how this operate? uh, the easiest thing would be that you know um, y equal to fx, you can say, or y equal to mx plus c. Some of you might have gone through that linear regression thing, y equal to mx plus c. So in that, m is something as if you try to translate into the machine learning, it's the pattern or it's a change that machines try to learn to give the output. What is the difference, pattern in that? What is the coefficient of that m by which if I get a new data, I'm able to predict, or I'm able to uh, give the response. F basically, right? Here, right? X will be our input, and y will be output. So what is the F part? Basically, we are trying to make our function smart enough from the data training so that it can predict for our new data, right? That comes in the future. Okay. Now let's try to understand. So here, there is a stats right there. So if you look at how from last one, not last, basically from last couple of years, you can see the growth. Here is example that from 2023 to 2024, how the investment of different corporates gone up. Um, you know, so it shows that how companies are investing on this. US is investing a lot, of course, followed by other countries as well. There's a lot of money going there for research and development to make sure that this ML is really coming out. That is something that helping the bigger environment, society, and of course developer ecosystem as well. Now let's start to understand that basically how to differentiate between traditional programming and ML, right? So traditional programming, if you notice what we do, we have some business rules, we get some input, and in the form of data, and then we output something, right? In machine learning, it's just really different. Machine learning, you give you have the output already, and you have the data as well. So you have input and you have output. You provide, or you will train that our model with these things, and then you understand the rule. Basically, you understand what is that coefficient, or what is a that number that will be applied to help predict the new set of data. So that's when it is different from the traditional approach. Okay. Moving on. So there are three different major categories of machine learning. One can be said supervised, unsupervised, and reinforcement. And we'll touch upon these with examples so that it is clear to you. What is supervised? Supervised is the one where you have the label data available with you already. Okay, you have input, you have output, and you train your model using these data. So model understand that for this input, here's the output. It understand different patterns, right? So that once it is given a new new set of input, it can predict output based on that. So it can be, of course, classified into further categories like regression and classification. So what is regression? When you want to predict some fixed value, that what would be the stock price after, in after 1 month, or what would be my rental income, what would be my house price, all kind of where you need looking for a one answer, not multiple answers. So one answer, that is called regression problem, right? Classification is on the as a names list. You give a different classes. For example, it could be binary like 0 and 1. For example, any mail is spam or not. You have disease protection depending on different demography data. You can say that, yeah, there is a chances of having any cancer or any of those health issues, right? It could be like any credit score. For example, any loan person or who is opting for loan is can be given loan or not. So things like that, basically, where you need to say yes or no or true or false, right? To get a binary classification. There is one more category called multi-class thing, where you have more than two answers. It could be like you are saying that, okay, what's the probability, right? It could be anything between 0 to 1, 0.1, 0.2, or you want to see that, okay, which day falls. So you can be any of those categories. Or let's say you have classification like, you know um, low, medium, high. So again, this is more than two. So where you have you can expect more than two, we call it multi-class classification, right? So that's about supervised. Coming to unsupervised, where is the difference? So in supervised, we already have the label data available. You already have the input and corresponding output, and then you're learning the pattern. In unsupervised, you don't have label data available. You have data, but it doesn't have a label on it. Means it doesn't know that what is input and what is output. So you got to, you know, throw the data into the system, and system or model find patterns by itself. Example like clustering. For example, you give the demography data of India. It can find different kind of cluster. It can find maybe through through economics, like who is rich, who is medium, middle class, who is lower class, right? It could be like age can be the other cluster, that who is younger and older, and things like that. So it finds pattern by itself. So that is clustering. What is association? Is more of like finding relationships. Like, for example, generally it is used in marketing, or you can say e-commerce, where if somebody is buying something, you try to offer them something related, so that they can buy, or they may most likely to buy. Better and better could be example. uh, Oil and com could be example. Any of those, right? Where you think that, okay, if somebody bought this, there's a high chance that they will buying others as well. So you try to tell them, show them different ads accordingly. And product recommendation is an example. Um, so that is about association, right? Some example you can think about, like customer segmentation could be a good example of clustering, anomaly detection as well. So like that, you try to find out with a or find patterns in an unsupervised. Reinforce, uh, uh, ML is literally new, I would say. It is getting traction nowadays, with the need of different LLMs needs a lot of data, and they need a quality data, right? So get a quality data, you got to get from, basically you try to get a feedback from users. You might have seen like in Netflix or some other platform where it asks you that you like it or didn't like it. So if you like it, they will show you more of those kind. If you didn't like, they will show less of those. So they learn from your users patterns, right? So basically you're reinforcing them to learn how you, as per your behavior. So it could be self-driving cars, where they learn that, okay, this is this sign, and this is not that sign. So if it is matching with, if their answer is matching with your preference, you say it is yes, so it's like a reward. They do more of those. If it doesn't match, it's like a penalty, so they do less of those. So right, so it is used in different robotics and other things as well. Could be in gaming as well. So typically there are three categories. There are some algo also that you can see for different categories that we'll go through them a little more detail in the coming slides. Okay, so let's move on. Now, what is the workflow? How basically we train the model? We talked about model training. So, what are the different steps involved, right? So, first is, of course, we should be clear that what we're talking about. What is the business problem we're trying to solve? That should be the first thing and super important. If that is not clear, I think most likely you will end up not getting the right results. Uh, Sometimes it happens that people find a solution and then they try to fit it the problem. That doesn't work. So you got to be have clear with the problem what you're trying to solve, and then of course go step by step to get to the solution, right? Next is data collection. So based on the kind of problem you are trying to solve with machine learning, you need to find different kind of data. Some data is available for free, like Kaggle and Hugging Face, and things like that. So these platforms give you data, and some data is proprietary, and you need to pay for it. Depending on what kind of data you're looking for, you may choose mix and match. So data is important for your model to get a good training. Next is pre-processing. So before you actually start processing, you got to clean the data, because oftentimes data is not that clean that you get from public sources. So you need to clean it. Sometimes you will find missing values, sometimes you will find outliers. So you need to use it well, you need to prepare it well so that it is not misleading you and you are getting the right results. Okay. Fourth is that before you train the model, you need to find some, you know, basically meaningful features. Basically, out of those data, which are the one that you want to focus on, right? Not everything is equally important. So you need to find the features that you want to basically focus on, right? Which really matters most. So that is something that you need to select those features, that okay, I care about for house, like, for example, house, and I care about, let's say, size of the house more than primarily whether house is new or old, right? Area of the house. So you got to choose that out of so many data, or so many patterns, or so many, you can say, not patterns, but so many features, which are the one which you really care about. So that you choose there. Once that is chosen, the next thing is important thing is, of course, you train the model. uh, there are different ways to train that. You train the model, and uh, once model is trained, you try to validate that, evaluate that. You look for the loss rate or error rate. There are ways to test that model. And sometimes you choose different batches while training the model, like we call it batches or epochs. You try to adjust your hyperparameters, we call it weight and biases, to make sure that model is really performing, or it's a learning rate, and basically training rate, testing rate is not too different, right? So you try to adjust those parameters while training. So that's when you try to evaluate sometime in the middle during training, sometime after that. Once that is done, you got to deploy that. Of course, you after deploying will get some endpoints, some in the form of API mostly, and then you need to put into task, and you should start using that. Again, it's a iterative process. In one time, it's very unlikely that you will get everything perfected. So it goes generally with different loops. I mean different iterations. So you will monitor that, check the performance of the model, and keep tweaking as required over time. Moving on. We talked about pre-processing. So what are different key steps involved, right? When we say pre-processing, and it is very foundational. If data is not clean, or all the efforts that you put into training the model and everything will not be basically will not get the right outcomes. So you understand it. I brought the point out, missing value, outlier, things like that. So you do exploration, checking the data, the quality of the data, and you do kind of steps to make sure that data is clean. You find out different features that you want to really cares about. which category of data you want to care about. Um, and then of course you look for different feature scaling, splitting that, how much data you want to put for training and how much validation and things like that. So these are some of the core things that you do before you actually start training the model. Okay. Now, algorithms, right? I think I was saying that we'll talk later. So now let's talk about it. So there are a different algorithm that, if you know, I think you can be a better, I would say, ML engineer. If you don't know, you can still manage for most part, but there will be some complex use cases or complex areas when the default settings may not work expected. So if you know these algo, you can adjust your parameters better, and you will understand what is happening behind the scene. Some of the popular algorithm could be linear regression, that is pretty simple, or most simple, I would say. There are decision trees, logistic regression for different use cases. For example, classification, it is used a lot. K-means clustering, and for clustering, it is used a lot. So there are a bunch of algorithm. There's so many, but I think at least you should know the core ones, the key ones, which are frequently used, so that you understand what's happening under the hood, and you're not lost when you don't see the right result. So you should know that, okay, what for algo is being used. If you know, you will be a better ML engineer. If you don't know, you can still survive for most part, but not all the scenarios. Okay. Few more algorithm like random forest, it is used. Uh, like that. There are neural networks is something that really important, especially for deep learning scenarios. We talked about uh, GPT and Gemini and Claude, right? Nowadays a lot. They are LLMs, right? And they are based on, of course, neural networks. Transformer architecture is what we call it, and transformation architecture, the base of transformation architecture is a neural network, and neural network is part of deep learning, right? As I said earlier, ML is part of AI, deep learning or DL is part of ML. So DL or deep learning is a subset of ML, and this is a specialized domain where we try to mimic the human brain uh, and how this works. That's when this neural network looks like. There is a neural network is topic of its own. Maybe sometime later we'll talk about it. But it's really a base for, I would say, LLM that we use nowadays. Okay, now once a model is trained, how to evaluate it, right? So there are different metric for it to use it. It could be precision metrics, accuracy metrics, right? Uh, we call it like learning rate, we call it training rate, things like that, or testing loss and learning loss, right? So the goal is that you are training the model in a way that it can avoid both false negative and false positives, and it is really giving you right results. Sometimes what happens that uh, model either it is like you know undertrain or overtrain, right? Both are not right. If it is undertrain, it starts giving you a different kind of problem. We call it underfitting. If it is overly trained, we call it overfitting. What happens is, if it is underfitting, means it didn't even see a lot of data or variety. So it's not generalized enough. It doesn't know. Maybe you might have trained with few thousand data, right? It doesn't work in current today's time. What is overfitting? So overfitting that you you have the data, but you trained way so much, so it try to remember those, right? Instead of finding generalization or diversity, try to mug up those data, and hence if it gets the new data, it doesn't answer well, right? So, and how to identify that? So when you train, right, that's where the validation comes into picture. That when you train it, if the testing loss or testing loss is more, most likely it overfitted, means training is fine, but it's not able to perform well during training. Sorry, during testing. So it has mugged up the data. So basically, you overtrained it. So that's where it is overfitting, right? So you got to validate maybe after every POC or every batches. Try to see how the uh, testing loss basically testing loss is looking like. If it is too much, you should stop there. If it is close to training loss, if training loss and testing loss are pretty close, I think you are done right one. But if the training loss starts increasing, sorry, testing loss starts increasing, means now we should stop it. Now we model is trying to overlearn, overfit, so that doesn't work. So that's where you got to pay attention. Now we're all practically usability of these, right? So we can see different kind of scenario in IT world, in technology world. It could be predictive maintenance, means it is able to see the patterns that okay, what is potential downtime, so that you are not waiting for it to crash and then do afterward. Rather, you are able to do it ahead of time. AI ops, where you try to find those patterns in operations. Different observability tools are out there to help you. They also are nowadays all well, I would say, uh, trained in AI kind of setup. Recommendation is in cybersecurity. All those are the great, I would say, example. Natural language processing again, with the boom of LLMs and Gen AI, I think this is something that really getting attention. Everything is, if not everything, at least most of the things are now people, it is exposing, this model are exposing us to talk in a natural language than in technical language, right? So that's when it is getting a lot of attention, a lot of use cases around there for customer chatbots and things like that. So um, it really kind of driving the world nowadays. Okay, so what are the key takeaways of all of this system, right? Today's session. So again, no free lunch theorem. What it says is that one experiment or one algorithm doesn't work for all, right? It's like a no silver bullet. Also, you can say that every scenario is unique and different. Of course, you can find a pattern, but it's not that one algorithm will be working for all the scenarios. No. So you got to, that's where the understanding of underlying architecture is important, so that you can understand that okay, what is fitting for any cases and not like same thing is working for all. Quality is certainly important. If quality is not good, all the effort that are going up training, evaluation, things like that is not of much use. It's a waste of the investment and time and effort. Again, third thing is that don't try to have a big bang. Really rather have it start small, start simple, play around with that, and keep checking, keep tracking, keep monitoring, and slowly, gradually make it bigger. Right. That's how this model operates. That's how this the good use of model. Uh, they learn in the iteration. So aim for that. That is practical. Of course, validation strategy we talked about earlier, that nowadays people are splitting the data into aspect like training, testing, and validation. So validation is something that's kind of between training and testing. So interim kind of testing, you can say. So you can find any issues or underfitting, overfitting scenario in early in a phase, rather completely training that knowledge checking, right? So you should have those strategies as well. Of course, monitoring is important. You can't just put once and then enjoy, right? You got to see that how the model is performing. Check about that whether you need to have a periodic, I would say, thing on. How is whether is requires any further fine tuning and things like that. So you got to monitor the output as well. And of course, performance and interpretability, right? So don't think that what I'm saying is the two ways to look at, right? One is that you have a generalized model that is good in, I would say, in many things, versus a specialized model, which are great on certain things. So you got to choose that. Don't expect generalized model to be a great, because that's really it's really hard, because uh, nowadays we have model which are like 100 billion trillion also nowadays models are available. So data is huge. So generally it is recommended that if you're looking for okay results, fine, go with generalized model like GPT. But if you are looking for a specialized model for certain domains, go for them. If you need a better results, like fine-tuned models, right? So they are fine-tuned for certain domains. So that may give you more, I would say, more better results. So don't try to get specific details or Don't aim for highest accuracy in a generalized model. They're not meant for that. So use your use case properly, and go about properly. That's pretty much, folks. Today we'll connect later for next set of we'll keep learning together. So keep joining my session. Thank you.